Hello. So this video will be about the power and torque curves for our powertrain. And I'll be focusing more on the theory side of this instead of like what what is it called? Like what we do in practice. I might talk about it at the end, but mainly just to get you guys familiar with the concept of a power and torque curve. So I'm just going to be doing everything on script or like snip because I'm lazy. So what a power and torque curve is it basically describes the relationship between your torque, your RPM, and your power. So if you guys know, the amount of power that you use is going to be equals to torque. So torque times angular speed. So this is the generic formula. And what this basically saying is if you keep torque constant and increase speed, you'll need more power. If you increase torque and keep speed constant, you'll need more power. And then if you increase both, you're going to need more power. Decrease both, you're going to need less power. Pretty self-explanatory. And so the formula we use is basically some dimensional analysis. But this is rads per second, but we use RPM. So we just convert using dimensional analysis but to rotations per minute. And we make this kilowatts because kilowatts is the common thing we use. And the formula becomes kilowatts is equals to the torque, which is in newton meters, times RPM, and over this factor 9,549. This is again just solved by converting and then this 1,000 factor that you get for the kilowatts. Not that deep of a conversion, but anyways, yeah, we have this conversion. And so um, what happens is I'm going to draw a chart over here. This is RPM. This is power. And then we'll call this over here torque. Torque. When you're at 0 RPM, you can have 0 power. It's not possible. You'll just have 0. Because 0 times anything is 0. And the second you get to 1 RPM, what is your power going to be? Well, when you start off, you can always be at your peak torque. Electric motors are very nice at that. That's why they're very good at acceleration. That's why you don't need a gearbox. From the get-go, from 0.1 RPM, you can have max torque. So what we're going to say is that let's say your torque max is 150 newton meters, right? So 150. So you're going to start over here, right? And so your torque stays pretty stationary. And so as your RPM increases, your torque stays constant, your RPM increases. What is kilowatt going to do? It's going to increase linearly. So you're going to have this increase linearly, right? And so is it going to increase linearly forever? No. We have an 80 kilowatt cap, so at most we can output 80 kilowatts of power. That's according to rules. And so what we have is we have a limit of 80 kilowatts. So let's say this goes up and up and up, right? And this gets to 80 kilowatts, right? 80. So then what happens then after it gets to 80 kilowatts? Well, then we have this becomes a constant. So 80 times 9,549. So 80 times 9,549. And then we will divide by the RPM. This will become equal to torque. And so this basically takes the function, like this is analogous to 1 over x. And so what you have is your power is not going to stay constant, right? Power is going to look like that. Let me change this color actually over here. Make it like blue or something. Torque. So then what torque's going to do, it's going to be decreasing. It's going to decrease like a rational function, right? And so as you go to RPM, let's say infinity, your torque has to decrease because, you know, this is a constant, right? So that makes sense. This matches physical reality. And so we have a cap though at 6,000 RPM. So our motor can't exceed 6,000 RPM. So we stop it at 6,000 RPM. And so what is our torque at 6,000 RPM? Well, we'll just solve that formula. So 80 times 9,549 divided by 6,000. So 80 times 9,549 divided by 6,000. So our end torque is 127.32 newton meters. So 127.32 newton meters, right? And so we drop to that. And so Like you might be saying, like, why don't you just run the entire thing at 127.32 newton meters, right? So you don't have your torque change. And that's what we do in practice because this we have software limitations, and so we can only input one torque value as of right now. In the future, we'll be able to do this. But the reason why like in theory, like doing this is because this will let us have the most power into the ground. So it doesn't really matter what your it kind of matters what your gear ratio is, but a rule of thumb is you just need to get the most power that you can into the ground. Like that is your goal. And so if you were to artificially limit yourself to have this much torque, right? 127.32 newton meters, then your power is also going to decrease, right? It's going to look like this, for example. And so, or it's going to like look like this. It's going to increase linearly until it gets to that point. And so there's no real point in doing that unless there's software limitations, maybe some driver feel. But overall, we want to get as much power as we can into the ground. And so we use this for our optimum lap simulations. So we'll input this for our power versus a torque curve. That's basically what it means when we talk about what's the power versus torque. And so we'll often make two of these or a couple of these. So 115 newton meters, that's the peak torque, right? That's going to be the torque you'll see during like acceleration or skid pad. But we can't run 150 newton meters for more than a couple of seconds. So for endurance, we'll set the torque limit to 80 newton meters, right? And then our torque curve is going to look different, right? Because 80 is less than this 127.32. So your power is never actually going to hit 80 kilowatts, even at 6,000 RPM. And we can check this. So 6,000 RPM times 80 newton meters divided by 9,549. 50 kilowatts. I believe it's 8,000 RPM. I might be tripping. I don't think I am, but let me check. Max 208. Let's look at the technical data. That's the old technical data. Let's see. Continuous motor torque. Yep, 80 newton meters. Right. And we're also not going to be using 80 kilowatts during endurance. Like we might only use 20 kilowatts, right? Like artificially limited. We might only use 30 kilowatts, right? In which case the graph will kind of look like this, except with like different values. And so we have a script that'll solve and make you this graph because otherwise, in OptimLab you would need 1 point like over here. Your power you need 1 point. Oh, that's a terrible color. Let's use like that. You need one like point over here. You need 1 point over like here. Like the torque is what you give it. Like 1 point over here, 1 point over here. I need like 15 points to talk about this rational function decrease, right? So yeah, it's kind of annoying. But yeah, we have a script that does everything. I'll make a video in the future to describe this. But yeah, that's pretty much it to deal with the power and torque curves. Pretty simple.